Hello. In this video, I would like to share with you different ways to measure probabilities of events. You should recall that probability measures how likely it is for an event to occur. Probability is reported with decimal values between 0 and 1, which can also be recorded as percentages between 0% and 100%. When an outcome of an event is certain to occur, we say the probability of the outcome occurring is 1, or 100%. Whereas when an outcome of an event is impossible to occur, we say the probability of the outcome occurring is 0, or 0%. There are three common methods for determining the probability of an event to occur that will be covered in this video. The first is called theoretical probability. If an event has n equally likely outcomes, and the desired outcome A occurs m times, then the theoretical probability of A is m divided by n. For example, suppose we would like to know what is the probability of rolling an even number on a fair six-sided die. This is an example of theoretical probability since we can count how many times an even number can occur, and we can count how many possible ways the event can occur. There are 6 equally likely outcomes on a fair die, and 3 even numbers, our desired result. So the probability of an even number roll is 3 out of 6, or when divided, 0.5. The probability 0.5 is also known as 50%. To say that the theoretical probability of rolling an even number is 50% means that if you were to repeatedly roll the die, say 100,000 times, and record the outcomes, the frequency of an even number rolled tends towards 50%. It would be expected that 50%, or 50,000, of the rolls end up being even. It is unlikely that you would actually roll a die this many times, and that's the exact reason why mathematicians work with theoretical probability. Theoretical probability is a good measurement for probability that is not determined experimentally. Experimental probability is calculated in a similar way as theoretical, but instead of counting possible and desired outcomes, observations and data collection is necessary. The probability of event A occurring is the quotient of the number of times a desired event occurs and the number of trials or observations. An example of experimental probability might be as follows. What is the probability of your favorite Major League Baseball player getting a base hit at his next at bat? In this case, it wouldn't be prudent to count the number of possible outcomes or the number of desired outcomes. This is not a meaningful request for this event. Instead, what can be done is observing a number of times this player comes to bat and record the number of times he gets a hit. If he came to bat 500 times and got a hit 151 times, then the probability of him getting a hit during his next at bat is 151 divided by 500, or 0.302, or 30.2%. If you are familiar with the sport of baseball, then you will recognize this decimal is also known as the player's batting average. The final concept to share in this video is that of compound probability. Specifically, the phrase compound probability refers to the likelihood of two independent events occurring. One event does not affect the other. If we return to the dice roll scenario from example 1, let's suppose we roll the die twice. Each roll is independent of the other. The result of the first roll does not affect the probability of the second roll. We can answer the question, what is the probability of rolling two even numbers on a pair of fair six-sided dice? Say the probability of event A is the probability that the first roll is an even number, 0.5. And say event B is the probability that the second roll is an even number, 0.5. The product of two independent events gives you the compound probability. In this case, the product of 0.5 and 0.5 is 0.25, or 25%. In fact, you could display all possible outcomes of two fair six-sided dice and count the number of two even-numbered rolls. This theoretical probability is the same as the calculated compound probability. Can you think of any events that could be modeled by theoretical, experimental, or compound probability? I challenge you to compute the theoretical probability of the occurrence of a desired event and see how the experimental probability compares. I offer a few examples that you might try here. Good luck.